Yes, we are looking at another question on surface area for maths and 6. So let's go through the question. It says we should calculate the surface area generated when x equal to 1 over 9 y squared from y equal to 0 to y equal to 6 rotates about the x-axis. So I keep on underlining important issues because the limit tells me how my formula will end. The rotation tells me how it starts. So as an NC student, I have to go to my formula sheet, look for that formula that starts with AX because it's a x-axis rotation. But such a formula must end with dy because my limit in terms of y. So if I go through my formula sheet, that will be the last formula on page number 6. So that formula has AX equal to the integral from g to c of 2 pi y times the square root of 1 plus dx over dy, all that square. So that is dy. So that's our formula. So this is the key thing with surface area. All formulas are on your formula sheet. The most important thing is to know how to get those formulas. So before we go to the calculations, you will now see that in this formula there is a y there, and the formula ends with dy, which means this y has the right to be here. So I don't need to be looking for the meaning of y. If this was x, I will go to the original formula to look for the meaning of x in terms of y to put there. But as the formula comes with a y, and the main variable is y, since the formula ends with dy, it means this y must be maintained there. So we can now start our derivative. So in this situation, we are very lucky that we are looking for dx dy, and the equation already makes x the subject for us. So that is what we get. So we differentiate x with respect to y. That means because we've made x the subject already, we don't even need implicit differentiation that we have been using in N5. So if I differentiate that, I'll get 2 over 9y. So I'm done with that part of the formula. The next thing is to square it. So I'll go on and do that. If I square dx over dy, it means I'm squaring 2 over 9y, which will give me 4 over, when you square 2, you get 4. You square 9, you get 81. That is what I'm saying. Then you square y, it gives you y squared. So I'm done with this portion of the formula. Then the next part is to add 1 to it. So if we add 1 to it, you get 1 plus dx over dy, all that square, which is 1 plus 49 over 81 y squared. So I think up to so far, the item under the square root has been taken care of because we got our x, we differentiated it, we got 2 over 9, we squared 2 over 9, it gave us 4 over 81, then we've added 1 to it. So up to so far, I think we are on the right track. So it's now time to substitute into the formula. So if we go into the formula, our c and d are the 0 to 6, then 2 pi is a constant. Since it's not in terms of y, we take it out, so it's the integral from 0 to 6. I already said our y has every right to be there because the active variable is y, which is the one that shows how your formula ends. So we have the right to keep our y there. Then we've got our square root of 1 plus 4 on 81 y squared dy. So looking at the way your problem is written, it's obvious that it's ready for integration. We just need to change the square root to become a power, which is nothing difficult. That will be 1 plus 4 on 81 y squared, all that to the power half dy. So just looking at that, we can see we are integrating a product, and in this product, the fact that you can differentiate y squared to get y already tells you that this is u substitution, where you have to take your u to be equal to what is under the power. But for NC students, they make life easy for you by putting a formula that can make your u substitution faster. That one we always refer to is as the power rule. So I will copy it here, then we'll try to navigate through it. So as an NC student, I will encourage you to practice how to use these formulas so that it makes life fast for you or easy for you. So this is what we call the power rule. So if you can get a problem that is written as a product and you can manage to make that product to navigate it to pass through that formula, then the integral becomes easy for you. So let's go through the procedure. What I'm going to do now, I'll copy my 2 pi out, then I'll give a little space there for my adjustment. I put my 0 to 6. Then in this product, whatever I'm supposed to call u in my u substitution, I put it in the position of f. So I'm capturing this portion, I'm writing that. You see that if we're doing u substitution here, in this product, our u must be 1 plus 4/81y squared. So I'll capture that u and put it there. So I'll get 1 plus 4/81y squared. My n becomes the power of that function, which is 1/2. Then the formula says whatever has been placed there, its derivative must come next. So if I differentiate 1 plus 4/81y squared, that should give me 8/81y, then dy. So what I've just done is what the left side of the formula says. Now, for me to conclude that I'm done with my u substitution, I must make sure that whatever I've done here does not look different from the original problem. This is the original problem we're integrating. So if there is a little difference, I will need to adjust it outside with a number. So if we start comparing, you see that your 2 pi exists, the limits are the same, the y you have there exists, then 1 plus 4/81y squared exists, the half exists. The only person that does not exist in the original problem is 8/81. So if I continue with this problem without taking care of the 8/81, then I've changed the original problem. So to make sure that the problem does not change, I will look for a number that can take care of this 8/81 and multiply it outside. And such a number is simply 81/8. So with this, I've done my u substitution in a single step. So what we've done here is the same thing like somebody saying, let u be 1 plus 4/81y squared. You look for dy dx, du, dy, you make dy the subject, you integrate, then you start changing in terms of u, all those things that take a lot of your time. So if you master how to use the power rule, which is a formula written on N6 formula sheet, page number 4, it makes your work very fast. So now I have to write my answer because I'm done with u substitution. So if I'm writing my answer, this item outside is a constant, it must be part of my answer. So if I simplify it, 2 simplify it to give me 4. So I'll be having 81 pi over 4 outside. Then to write the answer for this, and I'll use the right hand side. Whatever was in the place of f, I'll also put it to the right, which is this guy, then you increase the power by 1. So there I'll be having 1 plus 4/81y squared. The power will have to increase from a half to 3/2. Then I divide by the new power, which is 3/2. Then I put my limit from 0 to 6. So you see, I'm done with my integration. It's now time to substitute the limit. So my limit is a 6. So I'm going to take 6 and put it there and square it. That looks like a huge number. So I'm going to need the help of a calculator. So I will take 6 squared. That is 36 times 4/81. So I'll take 4/81. Then multiply by 36. Once I get it, I then add 1 to it. If I add 1 to it, it gives me 25/9. So I'm having 25/9, but this must be raised to the power 3/2 divided by 3/2. That's my upper limit. Then I start the process again. 81 pi over 4. Then I replace y by 0. If you replace y by 0, this whole item is 0. You are left with 1/3/2. So it's now time to talk to the calculator to do the rest for you, which I'm doing the rest. I must remember that 81 pi over 4 is a constant, or is a common factor. So I'll just do this part minus that part, and I'll do my multiply by 81 pi over 4. So I'm taking 25 on 9, 25 on 9, then I raise it to the power 3 over 2. 3 over 2 is the same thing as 1 comma 5, 1 comma 5 on 1 comma 5. So that one I'm done with this portion, then minus 1 on 3 over 2, which is the same thing as 2 on 3. So that gives me 196 over 81. Then I multiply by 81 on 4 pi. If I multiply by that, I get 49 pi as my answer. So my answer to this problem is a simple 49 pi unit square. If you're interested in decimals, it's still okay. That is 153,938 unit square. So guys, that's how you get the surface area for that problem.